Hi students, so welcome to Physics to Learn channel. So in last previous classes we have been discussed regarding the gravitation as the three videos, part 1, part 2 and part 3. So in this class we are going to discuss regarding the concept of gravitation constant by determining Cavendish experiment, and then characteristics of gravitation constant and acceleration due to gravity, relation between small g and capital G, which we are going to discuss. So before going to start the topic, please subscribe my channel, like it and then share to your friends. So regarding previous videos, so which I have been given below the description, if you have not been watched means just you can watch it. So we are going to the topic, the gravitational constant. So regarding this determination of universal gravitation constant, so we have been said that capital G value will be a constant. That value is 6.67 into 10 to the power of minus 11 along with units. So this they have been determined by using an experiment, so which I can call it as Cavendish experiment. So in order to explain this a Cavendish experiment, so which they have been assumed it as like this. So this is a bar, so which they have been taken it as AB. AB is a bar, so which they have been taken suspended from ceiling, and two small and identical leads attached to their ends. So this is a one body having identical, having a mass m1, and this is a one more body which is having a mass small m. So two large leads PS S1 and S2 are bought. So these are the S1 and S2, so which they have been taken, which are having masses capital M. The big PS attracts the nearby a small one by equal and opposite forces as shown in figure, because we know very well that whenever we are having two bodies, between them there will be a force of attraction because of gravity due to their masses. So therefore there is no net force on the bar but only a torque which is clearly equal to F times the length of the bar. So we have been studied in system of particles regarding the torque. Torque is nothing but R bar cross F bar. So whenever it is making certain angle, under that condition also which we are going to study. So where F is the force of attraction between the big sphere and then neighboring small sphere, which we can get it. So due to this torque, so what it will happen, the suspended wire get twisted until the restoring torque of the wire equals to the gravitational torque. So far we have been discussed regarding the torque, but we have not been discussed regarding this restoring torque. This restoring torque is a one whenever it is in rotatory motion. After some time it will tries to regain to its original position. So that is equals to here, which is nothing but, which you can call it as gravitational torque. So this restoring torque, which has been denoted by C into theta, where theta is the angular displacement, and C is called, which I can call it as a restoring couple per unit twist, and theta is the angle of twist, which is nothing but angular displacement, so which we can take from its initial position. If D is a separation between the big and small balls having masses capital M and small m, so under that condition, so what we can write. So with the help of definition, so which you have been studied it as, which is nothing but capital F is equals to m1 m2 by r square. So here capital G into capital M into small m by d square, so which we can be used. So if L is the length of the bar AB, then torque arising out of F is multiplied by F. So then the deflecting gravitational torque is nothing but F into L. So we have been studied already, torque is nothing but, so R bar cross F bar. So instead of R bar here, which we are using it as a L, so F into L, which we can write. So F value is nothing but capital G into capital M into small m by d square into L, which we can get it. So gravitation force already, which you have been studied it as F is equals to capital G into capital M into small m by d square. By substituting that, which you have been obtained it as, so at equilibrium this is equals to restoring torque. So restoring torque just now we have been proved, which is nothing but so C into theta. So capital G into capital M into small m by d square into L is equals to C theta. But we should have to find out the value of capital G. So by modifying this equation, so which we can get it as capital G is equals to C into theta into d square by capital M into small m into L. So if you know all the values and then if you have been substituted all these values, which we can get it as that as capital G value, which we are going to get. By observing the value of theta and knowing the values of other quantities, G can be calculated. That G value, which we have been proved it as, which is nothing but, so universal gravitation constant value is nothing but capital G is equals to 6.67 into 10 to the power of minus 11 Newton meter square per kg square. So with the help of this, which we can tell, this it has been explained by Cavendish experiment. Now we are going to see the characteristics of gravitational laws. So F is equals to capital G into m1 m2 by r square. So we know very well. So with the help of this, so what we can tell this. So already you have been discussed, gravitational force is independent of inverting medium. It does not depending upon the medium. So this gravitational force is a conservative force. So the force exerted by first particle on the second body is exactly equal and opposite to the force exerted by the second particle on the first, because we have been proved already in vector form F12 which is equals to minus F21. So the gravitational force between two particles acts along the line joining the two particles and they forms an action and reaction pair. So this gravitational force is an central force, so which we can tell that. So further, which is very important for us, acceleration due to gravity of Earth, which we are going to discuss. So as if we know very well, Earth is a sphere of approximately of a uniform mass density. A sphere compressed of a number of spherical shells. So for a point outside the shell behaves as a mass is concentrated at the center. So to calculate the force between the Earth and the point mass can be calculated by using Newton's universal law of gravitation. So if I have to measure the acceleration due to gravity inside the Earth, we have to follow the following procedure. So if this is a total mass, so which I have been taken mass of Earth, that mass of Earth which I can take it as mr, and then for this the radius which I have been taken it as re. If I have been kept an object inside the Earth as m, that depth which I have been taken it as a d. Under this condition, so how I can write. So for this, which I can keep it as consider a point mass small m kept at P inside the Earth at a distance r from the center of the Earth. So with the help of this, so which I am going to take it as r is a distance from the center of the Earth. Under that condition, so how I can write. From the center of the Earth to the point P, the Earth is assumed to be consisting of a number of shells. The shells with radius greater than or equals to r make up a sphere of radius r for which the point lies on the sphere. So mr be the mass of this sphere, which I am considering because we have been taken inside the depth, so then there will be a change in mass. Thus, force on mass at P now you have been taken from universal gravitational force. We can write it as capital G into small m into mass of the earth at a distance r by r square, so which I can be right. So with that, so which I have been taken it as modified because here mr represents mass of the earth at a distance r, which it can be changes. So with the help of this I can write it as mass per unit volume of earth into volume of the sphere, which I can be right. So this which we have been obtained as, which is nothing but density rho is equals to mass by volume. So with the help of that, which I am going to find out, so mass of the earth at a distance r, because if r value is changing, mass of the earth inside also it will be changes. So based on that, which I can write it as, so mass per unit volume of earth I have been taken it as me by 4 by 3 pi re cube. So that is mass per unit volume, that is which I have been taken it as mass by volume, that is mass of the earth by volume, which I have been taken volume of total earth, which is nothing but 4 by 3 pi re cube into volume of sphere of radius, so which I can be used, that which is nothing but 4 by 3 pi r cube. So with this I can get it as 4 by 3 pi, which I can get it cancel. Finally I can get it as mr value, which is equals to me into r cube by re cube, so which I can be obtained. So by substituting this value in equation 1, so which we can get it as like this. So f of r is equals to, which is nothing but capital G into mass of the earth into small r cube by re cube into m by r square, so which I can be get it. So this is the value of, which is nothing but mr, mass of the earth at a distance r, which they have been taken. So with this, so which I have been taken it as it gets cancelled, and then finally I can write it as f of r is equals to capital G into m suffix e into small m by re cube into r, which I can be obtained. So this is a gravitational force which it can act inside the earth. So if r value is changing, then force is also changing. So the acceleration experienced by mass small m can be calculated from Newton's second law. From Newton's second law, F is equals to mg. So that capital G into m suffix e into small m by re cube into small r. So with the help of this, small m gets cancelled. Finally we can obtain it as that small g, which is equals to, which we are going to use whenever depth we are going to use. This is a formula which we can be used. Capital G into me into m by re cube m into small r. So with the help of this, so which we can get gets cancelled. Finally we can get it as, in terms of small r, this is the final value which we can get. So this small g we are going to use whenever we are finding g value, which it can varies, so because of its height, depth and rotation. Based on that concept, this formula which we are going to use it in further classes. So gravitation intensity inside the earth, which we can be get it. If mass is situated on the surface of the earth, under that condition, if small r is equals to re, which I have been taken, so re gets cancelled, so which we can get it as that, which is nothing but small g is equals to capital G into me by re square. So this is one of the most important, so in further classes also which we are going to use it. So relation between small g and capital G, which we can tell it. So this is one of the most important one. So acceleration due to gravity on the surface of the earth, so which we can be obtained. So with the help of this, so which they have been set it as, so which is nothing but, so Cavendish calculated capital G by using the above formula, and then they have been find out that capital G value is nothing but 6.67 into 10 to the power of minus 11, so which will be a constant. So this is regarding the concept. So what I have been discussed regarding Cavendish experiment, and then characteristics of gravitational constant, and then acceleration due to gravity, so relation between small g and capital G on the surface of the earth, and then inside the depth of the earth. So thank you for watching.